Hello.
Hello, everyone. Welcome on next AI 42 session.
Yeah, and today we're really lucky to have Sandeep Pawar with us. Sandeep is a simulation and data analytics engineer, and his background is in research in mechanical engineering and product development, and he has always used statistics to analyze data. And for the last 4 years, he has been using data analytics and machine learning to improve manufacturing problems. And he has a master's in mechanical engineering in engineering management with focus on business analytics, and is also a certified Azure Data Scientist.
Yes, so let's first start for introduction AI 42 before we go to our session. So AI 42 is the motivation for starting it comes from the recognition that there is no good starting materials, and AI 42 is a strong team consisting of 3 Microsoft AI MVPs that strive to provide you with a valuable series of lectures that will help to jumpstart your career in the fields of data science and artificial intelligence.
And we, AI42, we aim to provide you with the necessary know-how so that you can help landing your dream job, as long as it's related to the fields of data science and machine learning. And the concept is quite simple, and what it is, it involves professionals from all around the globe that will explain to you the underlying mathematics, the statistics, the probability theory, together with data science and machine learning techniques.
And we will guide you through. All you have to do is follow our channels, enjoy the content every other week, filled with real life cases and expert experience. Don't you worry, we all started from scratch and we are happy to help build it up from there. You can always stop and rewind the videos or ask for clarification in the comment section. We hope to assist you on this wonderful journey and have you as a speaker one day.
Yeah, and also by creating cross collaborations with other organizations, we can give you the best opportunities to broaden your networks in the AI and data science communities. And with the combination of our offered services, we would be able to support less fortunate people and organizations that are not that recognized yet, even though they deserve it.
And our organization and also the conference is sponsored by Microsoft and Miles. We are humbled by the support we get from our contributors as well. Thank you, Levent Pongor, for all the beautiful graphics content, and me and Mary for the cool intro music before our event.
And we're in close collaboration with C# Corner and the global AI community. So all of our lectures will be available also on their YouTube channels, in addition to our own media. And we also have Nicolette Toth. She creates and reviews all of our text content that we use on our website, on our advertisement, and also during our sessions.
And you can follow us on Facebook, Instagram, and Twitter to become a part of growing community where we all share knowledge and fun. You will find every information that will bring you to an advanced level of the field of AI and data science.
And you can watch our recorded session on our YouTube channel, and you can also find our upcoming sessions on our Meetup page.
And we have also the code of conduct. And the code of conduct outlines acceptation for participation in our community, as well as steps for reporting unacceptable behavior. We are committed to provide a welcoming and inspiring community for all. Be friendly and patient, welcoming, and be respectful with each other. And you can find on our website this code of conduct. Yeah, so now we can start our session with Sandeep. Sandeep couldn't join us this at the beginning of the session, but he will join us at end. So feel free to ask as many questions as you like, and for sure he will answer you live later after the session.
Hello, all. My name is Sandeep. Welcome to AI 42. First off, I want to thank the organizers of AI 42 for having me here. So, I presented about the Excel for data science a couple of weeks ago. I thoroughly enjoyed it. Hopefully, you were able to catch my session there. Today, we're going to switch gears a little bit and talk about how to do advanced analytics in Power BI. And if you don't know about Power BI, Power BI is a data analytics tool that's used by many Fortune 500 companies for advanced analytics, especially for data analysis, business intelligence. You can also do some machine learning with it, coupled with Azure ML. In today's session, what I would want to do is, as a data analyst, you are often tasked with identifying insights from the organizational data. And as a data analyst, you will create these dashboards and then create these dashboards. But I want to show you some of the features that are available in Power BI that you may not have used or may not have heard about, or may have used but don't know how to use them correctly, and get a deeper understanding into using all these advanced features that are natively available in Power BI. So let's get started. I'm gonna share my screen here. Give me one moment. Let's go get going. Now, and then you should see my screen now. A little bit about myself. I'm a data analytics engineer at Cree Lighting in US in Wisconsin. My background is actually in mechanical engineering, but I got into data analytics about 5, 6 years ago or so. I primarily use Microsoft Data Stack, so Power BI, Azure ML, Python R. You can visit my blog at powerbi.com, and I'm also very active on social media, especially on Twitter. So follow me there as well at powerbi. In today's session, what I want to do, as I explained earlier, is I'm going to do things slightly differently. I'm going to start with a dashboard that's already built. So our focus is not so much how to create dashboards in Power BI. Rather, the focus is how can we use these advanced features, for example, clustering, regression, classification, time series forecasting, and get a deeper understanding into the data that otherwise is not possible by using the standard off the shelf or the traditional analysis techniques. Okay. What I'm going to do is, if we go to Power BI's website, and maybe if you Google for it, otherwise I can also provide a link in the description. And if you just Google for get samples for Power BI, you will see you will see a list of different dashboards that are made available to you by Power BI, so you can get started. The one that I'm gonna use is this retail analysis sample. So if you scroll down, I think there's a download original sample Power BI file button over here, or link over here. Just go to this one, the retail analysis sample PBIX, and download that one. And I've already downloaded that, which looks something like this. It has, I think, 3 or 4 different pages to it. So the first is the overview page. This is a retail samples, as the name explains. It's some data. I don't know if it is a synthetic data or a real data set, but from the looks of it, it does look like it's, at least from the structural point of view, it does look similar to what you would find in a company. So it has like sales product information, or sales data, product data, buyer segments, and districts. So if I go here, for example, click on sales data, you will see month ID, dollar amount, and then if we go to the store table, it has territory, open date, city name, you get the idea. I mean, it's a typical data set that you would find anywhere when you're working in a company. So this is the overview page. It has nice graphs, charts, and then district monthly sales here that shows what the trends look like, a nice bubble plot or a scatter plot, bar charts, and new store analysis and things like that. So when you are creating a Power BI dashboard, 99% of the time, the focus is on, uh, I would say, summary wise, or rather, creating KPIs and providing summary as to what has happened in terms of maybe averages, median, means, sum, and things like that. And you provide filters. What it does not do when you create a sample, create a dashboard like this, it does not give you whole lot of insights into the data itself. And what I mean by that is, if you've heard the word big data or data mining, a dashboard like this doesn't do data mining, per se. You do not understand patterns within the data. You can get an overall 30,000 foot level view, but nothing more than that. So for example, if we go here and then look at last year's sales, for example, in this case, this area chart, it shows maybe in the current year or the latest. This on the x-axis is the month. So overall, last year versus this year, it does not seem like there is any correlation between the two in terms of seasonality. But it doesn't really tell you a whole lot more than that, and which is what we're trying to do in this session, try to uncover what those insights are using some of the tools that are available or features that are available in Power BI natively. So we're not going to do any DAX, but we will use these features. So let's get started. So the first one that I'm going to do is, let's actually take this, the last year's sales versus this year's sales. I'm going to copy this and let's go over here. And what I want to do is, let's get rid of the fiscal month. And I'm going to take this and then go to the secondary axis and do a scatter plot. And in this scatter plot, on the x-axis, I want last year, and on the y-axis, I want this year. Okay, and I want to look at the stores, for example. So if we go to, or maybe let's start looking at the segment, and the what we are trying to identify here in this data, when you create a scatter plot like this, is each data point here, or each point here, represents a segment. And for that segment, so if I hover over it, for segment 3601, what was the sale last year and what is the sale this year? And you will find something like this very commonly in a business intelligence dashboard. What I want to do is, scatter plot is one of those things that is maybe underutilized and not very well understood in Power BI. So what I want to do is show you some of the features that are available in here. Okay. So we start with this. Before we get too detailed into this, some things that I want to maybe show you that will help you when you create a scatter plot. The first thing is, when you create a scatter plot, always keep in mind the aspect ratio of the data that you're showing. So in this case, we have on the x-axis is the last year sales, and on the y-axis is this year's sales. And if you look at the scale, it says 0.6 million. Let me zoom in a little bit. So 0.6 million over here and 0.6 million over here. And this may not always happen. Maybe sometimes the x-axis may be $0 to $10 million, whereas your y-axis could be a percentage. So there may not be. You could be looking at plotting two different things. But in this case, because the two things we are comparing this year versus last year, the aspect ratio of those two is 1 to 1. Okay, and when you have something like that, always make sure that you create the scatter plot as a or format it in a square as a square layout. And what I mean by that is, for example, you'll go in general, and maybe width would be, let's say, 500, and your height would also be 500, for example. Okay. Now, what happens if you don't do that? Keep an eye on some of these points over here. And when I skew the aspect ratio here, you will see the difference in how the distribution of these data point changes. If I go like this, if I make it longer and shorter, you'll see that these two data points are almost, they coincide with each other. Somebody who's looking at it and not deep into the data, you might think that, okay, these two are almost the same, this year versus last year. And these 2 points are very far from each other. When I go like this instead, these 2 points again are fairly close to each other, but it does tell us that for this point over here, last year's sales were slightly, or this year's sales was slightly lower than this, and these 2 points are now close to each other. So which of these is correct? Based on how you are showing the data, you may lead to some incorrect decisions or incorrect insight for your users. So when you are creating a scatter plot, always keep in mind what your aspect ratios are, and then create your aspect ratio based or create your layouts based on that. Like I said, in this case, we are trying to create a one-to-one relationship between the two. So I'll just change that to, let's say, 500 by 500 to give the correct correlation between the two. Okay. I would also change maybe the x and the y axis so that they have one-to-one correlation. So here, this is 600,000 on the x-axis. I'll just copy that, and on the y-axis, we want to have 600,000 as well. And that way, we can give a true correlation or a true idea of the correlation between the two. Speaking of the correlation, when you click on the scatter plot over here and click on the data analytics pane, which is right over here. So click on the analytics pane. You will see a lot of different options that are made available to you. And these are some of the advanced analytics options. And we will explore more, but I just want to get you started with some of the things that you can easily implement in your dashboards. You click on it. The first option is the trend line here. Click on that, and I'll say trend line. And it creates a trend line. And I'll explain what it's doing. But there are a few more options, and it would be best if I show all of them, and then we can understand difference between them. So we created a trend line. A few more options here, X, Y. These are pretty self-explanatory. Average line, max line, min line. There are 2 more options at the bottom here. The first line, the second last is the symmetry shading. And when you click on the symmetry shading and then click on add, it will create a symmetry shading, sort of a shading in here. Let me make it lighter a little bit so it's easier to see the points. And the third is the ratio line. And this is the ratio line. Now, as you can see here, all these 3 created lines that look very different from each other. Let me change the line of the ratio line here. So the ratio line is this red line. The difference in all of these is that the trend line, you can think of the trend line as trend line is this black line. Trend line as your line of regression, the line of best fit. So if you are creating, for example, if you're familiar with linear regression, the trend line will do a trend analysis, meaning find a line that goes through, minimizing the least square. It will find a line that goes through those points and fits those lines, the points the best. The ratio line on the other side is just a ratio of sum of your x quantity divided by sum of y quantity. And the way you would use that is it gives you, when you look at the numbers, it tells you compared to the overall average, how do your points lie compared to the average. So this point, for example, this segment 5071, it is slightly below the average, and it's the average is aggregating all the data that's in the visual. So it's looking at all the data. So it tells the viewer or the user that for this point over here, 5071, the segment 5071, in relation to your average, it did slightly worse. Whereas the points on above here, they did slightly better than overall average. The symmetry line, however, it doesn't consider any of these points. It only looks at the x-axis and the y-axis and creates a one-to-one correlation between the two. Meaning we have 600,000 over here, and on the y-axis is 600,000 over here. So it will just map out those points, one-to-one correlation between the two. It's a 45-degree line. So think of it as if it is 10 on the x-axis, the line, the diagonal line that divides the two, divides the square is 10 on the x would be 10 on the y, 100 on the x would be 100 on the y. And that gives you a good understanding as to which way the points are. In this case, the trend line and the symmetry line, they are pretty close to each other. But if they are not, and in most cases they will not be, but this tells you that the points in the gray or this bluish gray shade over here, these segments over here, they did significantly better, or they did better this year compared to last year. So that, visually it gives you the understanding or insight to the user that to what that means. The trend line, on the other hand, that's a degree of correlation, degree of fit between the two. So what this is telling us that if we want to predict this year's sales based on the last year's sales, we can do that because there seems to be some correlation between the two, and we can do that to a large extent. And one way to think about that, like I said, correlation between the two, is if I copied this data and I've already created a table that summarizes using some tags. If I go to this segment summary, for example, and then copied this data and go over to Jupyter Notebook, I've created a Jupyter Notebook over here. I won't go into the details how I created this. If you go to my blog, you will see some session on that. But in this case, if I create a correlation plot between the two, a linear LM plot between the two, you'll see there is a degree of correlation between them is 90%, and it matches this correlation plot or linear model plot between over here using Python and in Power BI, it matches. And what this is telling you is the degree of correlation between the two. And in your application, depending on what you're trying to convey, you can use different things, and you can use those things in your analysis or in your insights. Okay, so that's one quick way of finding quick insights from your data. You can also add zoom axis in here if you want to zoom in. And as you can notice, these lines change. In fact, the trend line will change depending on where you are over here. And you can get a good understanding of this. So this is based on the segment. What I want to do next is let's copy this, or in fact, let's stay here. And instead of segment, what I want to do is look at the store. And there is a store, should be a store name. So store, and there should be a name, for example, and go those details by there. In fact, you know what, let me create a new one. So we're going to start with this year's sales. That goes on the x-axis. Last year's sales. That goes on the y-axis. And let's say the name of the store name of the store goes in the details over here. Now, in this case, if we see the degree of correlation between the two is not so linear. There are definitely something that's going on in here. So you have two different clusters of data that you can clearly see in this case if we do divide it by segment. I also have an example prepared that I want to look at. Yes, if I take, for example, last year versus this year, and let's get rid of this and the store number. Now the relationship between the two is not collinear, and it's not linear. You can see the curvature between the two, and in this case, the symmetry shading doesn't help. So it won't actually work in every case, but you can clearly see that there is a curvilinear relationship between this year and last year if we do it by the store number. And you can see visually that there is a cluster or two different clusters of data. So in this case, for example, these clusters over here, they have low sales and low sales this year and last year, whereas this cluster over here has high sales and high sales last year. Okay. In Power BI, you can create clusters and cluster analysis. Clustering is an unsupervised learning technique, and what it does is based on the data that you have, it will. We'll go into the details in a bit, but let's get started. If I go here and then click on these three ellipses over here in the top right corner, and then click on automatically find clusters. It will show you a message, and I'm going to call this as bivariate. And the reason why I'm calling it as bivariate is because we are only looking at two variables, that is last year versus this year. And it will ask you for a description. It says cluster for store number and number of clusters. I'm going to leave the number of clusters as default. We'll come back to that later, but the number of clusters here as default, and then click on OK. I've already created this, so I won't go into that. But as soon as you do that, what Power BI will do is it will automatically create a calculated column called based on the name that you have given. And in this case, I gave the name bivariate, and it will add that to the legend in this case. Visually, like what we were saying earlier, there are two different clusters that we were seeing, right? One over here, 1, 2, 1 and 2. Power BI, on the other hand, it looked at the data and it did some clustering and ran a clustering algorithm on it. And then it identified that there are three different clusters, cluster 1, cluster 2, and cluster 3. And the clusters here are, in this case, is like this cluster over here, and then a small orange cluster over here, and a red cluster over here. So how did it do that? So what Power BI does is it uses what's called as a Kmeans clustering. And we won't go into a lot of details, the technical details of the algorithm, but just to give you an understanding as to how the clustering works is, imagine a cluster like this, which is similar to ours, the top left corner. The K in K-means is the number of cluster, and the means is the mean of that cluster. Okay, so what it does, it will start with randomly, it will create two clusters at random. It will initialize two clusters, and it will assign some of these points to these clusters. So for example, in this case, it created this cluster 1, X and X, and it assigns two clusters to it based on the distance. It will calculate the distance. So this point is closest to maybe this half, and these points over here, the red points, are closer to this half. And then it will calculate the distance between these centroid, the mean of that cluster, and these points. And then it will look at two things: the intercluster difference between two, like how far these clusters are from each other, and then variation within the cluster, so inter-cluster and intra-cluster. And it will keep assigning the points iteratively until the inter-cluster distance between these clusters is maximized and inner cluster difference is minimized. So as you can see over here, it will start with randomly assigning the points. And as you go progressively, it will find a line of separation so that they are well separated from each other, and as well as they are densely packed with each other. That's how the K-means clustering algorithm works. There are lots of variations of the K-means clustering, but that's basically the gist of it. When Power BI, when we went over here and then we created, hey, Power BI, create a cluster for me. So when you went over here and then clicked on automatically find cluster and then number of clusters as auto, what Power BI did was it went and looked for different number of clusters, and then depending on its own algorithm, it found that 3 clusters define or minimizes those two, or optimizes the criteria that we talked about, the intra-cluster and the inter-cluster differences between all of these clusters. So let's go here and let's add that. So this is a bivariate cluster, and what this is telling us again is there is 3 different segments that it found, or stores that it found, and based on this you can start analyzing the data. And let's say if we go to this bivariate, and let's go here. So there are 3 bivariate, and in each of these, if we count, in the first cluster there are 66, in the second 14. If we look at the sales of all of these, so sales last year, so sales, total sales, maybe sales this year, so yeah, it should be drop here. You will see that there is some difference between them. Looking at it, if we were to look at this, I would think that this point over here is maybe of an outlier, and that's one of the limitations of using a K-means clustering, that it is susceptible to outliers, and it does not work well with concave data. Concave meaning data that is shaped like this. If it is a straight line or densely packed points, it works very well. But when you have concave data like this, it doesn't work very well. So in this case, for example, I would have thought that this would be one cluster and this would be another cluster. But it always works in globules. It always creates circular patterns in the data, even if it does not look so intuitive to you. And based on this, you can give this to your end users and they can analyze the data. Now, understandably, this is not very intuitive as to understanding what this means, and you can't really use this. So there is another way of adding more matrix to this and then creating multivariate clustering. And for that, you can't really use bivariate or the scatter plot. You'll have to create a table for that. So we'll create a table. So I'll go here, and then we were looking at the store, right? So we'll go to store name, for example. So that's my store name. We'll look at some of the matrix that are already in here. I did not create any of these. These KPIs or the measures are already in there. So for example, we'll look at total sales variance for this year. What's the age of the store? That could be one KPI. Maybe the margin variance. So let's drop that. There is a markdown. So if that store, it's a relative measure of if that store, how many dollars it received by selling regular versus markdown products. Okay, Then maybe total sales variation, we added that, margin variation, sales per square foot, that would be a good one. So total sales per square foot. So let's add that one. What else we got? I think average unit over here. So the total sales variance is comparing this year versus last year. Age is the age in terms of years, how many years that store has been open. Marginal variance, margin variance, how much the margin has varied. Markdown versus regular versus markdown. That's the dollar amount of how many regular merchandise you have sold versus to markdown at discount. Sales per square foot and average unit or average amount per over the total quantity. So 1, 2, 3, 4, 5, 6. Yeah, 1, 2, 3, 4, 5, 6. And now if you click on these three ellipses again, you will see that automatically find cluster. And when you click on this automatically find cluster, I'm going to name this as multivariate. And then leave the number of clusters as is, like we did earlier. I've already done that, so I won't do that, but let's cancel that. And like I said earlier, when you do that, it will create a multivariate, it will create another calculated column that's called multivariate. Okay, that's the name. And then it will create this column, cluster 1, cluster 2, cluster 3. And now it has created clusters using the same K-means algorithm by looking at all these different KPIs that we have created. Now, one caveat here that I want to point out is this won't work. For example, let me copy this and let's cancel this, and let's look at some of the so let's go to, let's say, for example, are there in so I want to look at a column. Yeah, so if I go here, I'm just going to add something here, okay, and then go to automatically find cluster. Second. So it did create it. So maybe in the new version they did that. But for this to work, first it has to be an explicit or implicit measure. So it has to be summarized. And then the second thing is that it has to be a numeric quantity. If it is not numeric, it won't work. Okay. So let's look at this. So we created this multivariate cluster in this case. Now the question is, how can we interpret this and what exactly is it telling us? So what I'm going to do is, let's first look at this multivariate cluster. I'm going to put it right over here. And then some of the things that we looked at earlier. So this, and then how many multivariate clusters, the number of clusters that we have in, or number of stores that we have in each of these. Age, so let's look at the age column. Let's go here. Let's go here, the number of, and then I'm also going to look at this. Let's pick one more KPI that we have used in this case. Let me go to KPI. And then maybe the regular versus markdown, for example, regular versus markdown. Okay. Now the question is, it created these 4 clusters for us. How do we interpret this, and how does it help us get insights into the data? And we can analyze that or understand that by looking at the differences among these clusters. We can do that by creating a parallel coordinate chart. Now, this is something that's not available natively in Power BI. You can go to the custom viz library, import this, and then create a, multivariate cluster or parallel coordinate from here. And if I start adding things in here, so what I want to do is multivariate, start as my category, and the things that we were looking at earlier. In fact, let me cancel this, copy this, and then maybe this would be easier. I remove, and then create a multivariate. Okay, there you go. And I'm gonna remove the name. There you go. And from this one, let me remove the multivariate cluster. I'm going to select everything and not include the blank. The blank is there because some of the values are null. So it created another one that's null. And this is how you would understand how these clusters are created. So for example, let's see if we see on the x-axis over here, we have cluster 1, cluster 2, cluster 3, and cluster 4 on the first bar here. If you look at the age, it clearly found it divided these 4 clusters first into 2 by age. So there are 2 groups that are new. So higher the number, meaning they are older stores, and lower the number, meaning these are newer stores, right? So there are, out of these, it divided the stores into 2, newer stores and the older stores. So it's looking at the pattern in the data. Let's compare how these new stores are doing relative to each other. So new stores, for example, in this case, there are again, this blue line is the cluster 4 and orange is the cluster 1. This cluster 1 and cluster 4, they are different in terms of the margin variance. So one has higher margin variance and the other one pretty much nil. Both of them, in terms of average or versus regular, what they how they sell things. So the cluster 1, for example, it sold more markdown compared to cluster 4 stores. And on the other hand, if you see, whenever you see in a parallel coordinate chart that are things that are crisscrossing each other and crossing each other, that means they are behaving differently from each other. So this gives you a lot more understanding about the clusters and how all these different stores are behaving, and understanding pattern in that in the data. We can go one step ahead here, and then add, let's say, if I go here and then drop maybe the map and then go to postal code, let's go to the postal code location. And now if I add multivariate as my cluster in the legend, you will right away see the pattern in the data. So if you see in this case, we can clearly see these blue lines, which is cluster 1, blue circles rather, these cluster 1 is in the lower, in the southern part over here, whereas these blue dots, darker blue dots, are in the upper northeast, and these red are in the eastern part, and then so on and so forth. This will also help you understand. So for example, in maybe you have somebody who is in charge of the southern territory over here, right? These blue dots, and we can see these orange dots, and this helps us now identify in this blue region over here, what are these yellow dots doing? And then we can go back and look at cluster 1 and cluster 3. And then we can understand from this that what exactly is the difference between cluster 1 and cluster 3. So cluster 1 is over here and cluster 3 is over here. And we can see cluster 1 is the newer stores. Cluster 3, on the other hand, are older stores. They also behave completely opposite in terms of margin variance, and also in terms of the sales per square foot. The newer store has much lower sales per square foot, and the older stores have much higher sales per square foot. And based on these insights, you can take more actionable steps and decisions as to how you want to create maybe KPIs or compare all these different stores to each other. And something like this is not typically possible when you create DAX measures that only look at time intelligence based measures, or you only look at averages and medians. To get deeper insights into the data, you'll have to create things like this. We can take this even one step ahead and use what's called as, or would use what's called as a key influencer. Let's create a key influencer here. I'm going to add my clusters here again in this case. So analyze the clusters. In fact, it would be easier again if I just copy this, cancel this, and then paste it over here. And I'm going to click on the key influencer visual. And we want to do this by name. Let's get rid of that. And I want to do this by name. And as soon as you do that, it will create a few things for you. So the first one is that let's not do cluster one, for example. What distinguishes cluster one? Which of these KPIs differentiates cluster one from the rest of the cluster? And the number one thing is the age. That age in general is lower for cluster one. If we go to cluster two, what drives cluster two is again the age. But the second important factor is average dollars per unit total this year. Whereas if we go over here, cluster one, not only the age, but the regular versus the markdown. So again, that gives us an understanding that if we are analyzing or looking at the data or creating some sort of a KPI for stores that are in cluster one, then you should be looking at the regular versus markdown KPI as their primary metric, because that's what really defines them, or that's what really distinguishes them from the rest of the stores. Okay, we can do the same thing. Cluster three, again in this case, it average units, and let's look at cluster four is regular versus markdown. And you can go through and click on each of these, and it will give you an understanding how these clusters are doing for that selected measure across different things. You can also click on, if we go to cluster one and then click on top segment, it will also identify things for you that are usually not possible. So it identified out of the 42 stores that are in cluster one, 32 are behaving differently from the other 10. And let's click on this, and it will tell us that for 32 stores that are within that cluster one, their regular versus markdown average value is less than or equal to 9.1. And the other one is greater than 9.1. So again, deeper understanding into the data that within that cluster itself, there are even pockets that are different. So maybe this regular versus markdown, and it gave us that KPI or the value as 9.1. So you could use that as a baseline to further understand what is the significance of maybe that number 9, or further do deeper analysis into how can you increase that number to 9, or the second cluster, which is clearly doing much better because it's selling more regular items. There are fewer number of stores, only I think 12 or whatever stores in it, whereas this one has more. So maybe create some sort of a strategy so that you can push those stores from this cluster or this segment 2 in cluster 1 to segment 1. Now, how is this key influencer working? It works by, it's pretty actually very intelligent in the way it works. it identifies, it actually creates a machine learning model for you on the fly, and it does it, really quickly, and identifies the influencing factor for you. If you are using a categorical influence, or trying to identify categorical metric, like in our case, we are trying to understand what distinguishes cluster one, so a category, then it creates a logistic regression model. Whereas if it is a continuous factor, like the sales amount or margin variation, then it will create a linear regression model for you. And you won't have to do that. It does all of that automatically for you, and then create these insights for you. Now the question is, okay, how can you trust it, and how well does it work? Well, I started looking at that. In fact, I have an hour-long presentation on how the key influencer works and how to use it. So check out my website, Power BI, and you will get understanding of that. But in general, if I create the exact same clustering in Power BI, in Python, using Jupyter notebooks, it actually works out quite well. So I created a Kmeans clustering, identified the labels, and then ran a logistic regression model. And in overall, the accuracy, I should say accuracy, the AUC, but let's use AUC as the proxy for accuracy, is 91%. So overall, Power BI did a pretty good job of identifying these clusters, and we can clearly, it is about 91% good at identifying these different clusters. The overall features, or the things that are important in understanding what drives these different clusters: sales per square foot, the age is number one factor. In the opposite direction, average price, regular versus markdown. So those numbers also quite agree with the overall model that Power BI created in this case. You have to be careful as to understanding how this algorithm works. It will randomly sample 30,000 data points from your data, and then create these models. So if you have data that is highly nonlinear, or large amount of data, it may not be as accurate. So use it with caution. Again, I have an hour-long session that I created for this, that you may want to check out. But overall, it does a pretty good job, and to give you an overall understanding as to how how to get deeper insights into this. Now, in some cases, you may not want to show all of this to your business users. They may or may not understand it, but I usually use this to in my work. If I'm just creating a dashboard in Power BI, to figure out what do I want to show, and how should I show the data, what KPI should I create, what baseline should I create, and things like that. If you create a clustering algorithm, or a key influencer, you may want to train or educate your business users as onto how to interpret these things. One limitation of using the clustering algorithm is that if you have new data points, so let's say you fast forward 1 year and you have new data, Power BI won't update your cluster. You will have to go and then run the clustering algorithm again, and then get these new clusters. And these new clusters, they may or may not match your old cluster. And the reason for that is they might be similar, but they may not be. Remember what I said when I explained this, that it will randomly create 2 center points, or 3 or 4, the number of keys in here, to identify the clusters. And those are randomly created. So depending on whatever you may get different result. So and again, depending on the data, your results may or may not be same every single time. So use it with caution, understand exactly what it's trying to do, and then it will help you get better insights into the data. The last but not the least is forecasting. Unfortunately, we don't have a lot of time to go into it. What I suggest is you go to my website, Power BI again, and then I have written 2, 3 blog posts in detail about time series forecasting and in very long details of exactly how it works and how to interpret it. There is also a session, I think, that I did on forecasting that you can look at. Should be somewhere over here. Yeah, should be somewhere over here. But you can look at that. It's also an hour-long session that goes into insights or deeply into how forecasting in Power BI works. So hopefully you can take a look at those, and hopefully you found this session helpful. Um, if you have any questions, please drop them in the chat window. I'll be happy to answer your questions. If I cannot answer your question right now, I'll definitely make sure that I'll respond back to you in the chat. So thank you again, AI42, and yeah, see you again. Bye bye.
Hi, Sandeep. What a great session it was again. It is so awesome to see you back at AI42.
Thank you. It was a pleasure.
It was our
Yeah.
pleasure.
Yeah,
And we have a
welcome,
few
welcome back,
questions,
Sandeep.
right?
Yes, we
Yeah,
have a
sure.
couple of questions here, so let me just find them in the chat there. So here comes a question from Endel, who says, any suggestions on tools that analyze multivariate clustering analysis using both numerical and categorical variables?
Yeah, so great question. So we looked at how to do multivariate clustering in Power BI using when you have numerical data. For categorical, you can create, you can dumbify them, so convert them into numbers. However, it will be tricky and may not work correctly. So your best bet for that would be either to use Python or R, or do the analysis outside of Power BI, and then create the clusters, understand how these clusters are created, and then using maybe rule-based approach, you can define them in Power BI. So we saw the parallel coordinate chart I created, right? So you could do something similar in Python outside of Power BI, identify where for each of those centers or centroids, what are the averages, and then define them in a DAX measure inside of Power BI. So that would be one way to do that in Power BI.
Okay, thank you. We have another question. We load that up. So that's from Gabriel, who says, is it possible to build a correlation matrix in Power BI?
Yes, it is possible. So if you go to the quick measures gallery in Power BI, it will let you create measures between two columns and a category. However, to create a correlation matrix, in fact, I saw that one recently by Elite BI. I think Parker is his name is Parker, and his YouTube channel is Elite BI. I think he created a correlation matrix. He has a video on it, so go check it out. But it's possible. Yes, it's not straightforward, but definitely doable.
Mm-hmm.
Thank you. Do you have other questions?
Yes, I had a small question here, Sandeep. Is it somehow possible, can you somehow interact between Python and Power BI, so you can, offload something to Python?
You can. And it's a touchy subject. I know a lot of people, they use Python and R in Power BI, and I've written a blog post on it. I would use that, something like that, inside of Power BI during development, but not for production. And the reason for that is Python or R inside of Power BI. It's not production ready yet. There are a lot of limitations. You can't use, for example, enterprise gateways, or if the Python script that you have written, it takes too long to load. There is a timeout on it, and so on and so forth. So you can check out my website for that. But in general, when you are doing the development, you can do that. For production, I would be very cautious of that. Another downside of that is, depending on the company that you're working with, when you use a Python inside of Power BI, Power BI on the back end, it there are security limitations on it. So you have to be aware of that. If you work in a company that has, a lot of is concerned about data security, I wouldn't use Python or R inside of Power BI. But now, we're talking about the same subject. I did a session just a couple of weeks ago on how to use Jupyter notebooks with Power BI. And you can take a look at my website for that. But in that, I show my workflow as to how you can export data from Power BI to Jupyter notebooks and work on Python or R, do your analysis, and then so you can do that.
Oh, nice. Thank you.
Yes, we learned a lot again today. And, it's so cool that we had like so many people joining us today. I think all of us learned a lot today from you again, Sandeep. And with that, I want to say a big thank you again for joining us and sharing your knowledge with us. And to the audience, your journey doesn't have to end here. Maybe I'm going to share my screen and show you some more info where you can go from here.
One quick thing before we go that. So I have another session. So this was the part 1. So we have a part 2, which is, I think, in a couple of weeks, right? In a couple of weeks.
Yes.
The viewers, if you have any suggestions as to what you would like to see in part 2, any topics that you want to see, let me know in the discussion. Otherwise, I will. What I was planning on doing was doing the showing AutoML in Power BI, how it works, how to productionize it, and we won't. I promise, we won't use, just like this session, we won't use any Titanic data sets or anything. It will be more practical. So yeah, let me know if you have any thoughts on that, and I can work on that.
We got one last question here from the audience, so we can take that. It's from Tobe, who says, how do you manage production and development PBIX files in Power BI?
So if you have PPU or premium, you can use the deployment pipeline. If you do not have that, if you work in a shared capacity in Pro, I just use my own workspace for development. I know some companies, they have a workspace that dedicated to a development and another for production. So I create something, for example, push it to my development workspace or my own workspace, share it with my users, do UAT, user acceptance testing, validation, and everything. And once it is ready, then push it to the production workspace. And we use DevOps for everything. So everything is version controlled in DevOps. Yeah.
Yeah, thank you.
Yes, thank you a lot, Sandeep. And actually, I wanted to come to this as well, that you're coming back to us in 2 weeks. And before that, if you want, you can always rewatch our sessions if you go to our YouTube channel. And there you can see all the previous sessions we had also. But you can also go ahead and prepare for the next session that is coming up with Sandeep. And with scanning the QR code of our meetup page, you can see all our upcoming sessions as well. That is as we said already, on the 3rd of November, we come back to Sandeep and we continue our journey with Power BI. And then Terry comes and talks about Azure Databricks using Apache Spark and Advanced Analytics, which is going to be really cool as well. And then on the 1st of December, we're going to have Laila, who is going to show us the amazing Azure Machine Learning Workspace. And I really hope we will see you there together again. And just for fun, I'm also sharing that tomorrow we are going to meet in person with the Copenhagen community of global AI community. And I hope like a lot of more events are going to happen soon that is in person. And with that, we want to say a big thank you again for joining us. And the team of AI42 really hopes that we will see you back in 2 weeks together with Sandeep, and we continue with Power BI. So thank you a lot again.
Yep, thank you so much. Bye-bye.
Bye.